Hi guys and girls, a video here on binomial hypothesis testing. So what it is it's going to use binomial probabilities to judge whether a statement or particular question is true, or whether there's been enough of a change in something to say, well, actually we thought this was going to happen, but actually the data says that that's going to happen. So let's crack on. So a hypothesis test can either be one tail, there's a one, or two tail. So a one tail test involves the direction. So whatever we think is going to get to be more or less, and it's usually a prediction. A two-tail is just going to say that it is changed, but with no direction. So we don't know whether whatever it is we're measuring is going up or down, we just know it's not what it was before. And then some notation. H with a little subscript of a 0, H0, is the null hypothesis. And that means that nothing has changed. And then H1 is the alternative hypothesis, or alternate, doesn't really matter. And this is where you put your prediction. Right, so there is going to be a change. So it could be more than, less than, or not equal to. So these two are the one tail, and this is a two tail statement. So the way you do it is you set up your hypothesis and you state the thing that you're going to be measuring. So it would be P, and that is usually it's proportion of, and the thing you're measuring. Right, so it might be proportion of people who like pizza. It might be proportion of people over 25. You know, it's the thing you're measuring. You've also got what's called a significance level. Can't spell. And the significance level is kind of your little bit of leeway. So it's usually a percentage, and it's normally kind of 1, 5 or 10%. And it's the percentage allowed to make the wrong conclusion. So, for example, a 5% significance level would say, okay, I've allowed myself to be 5% wrong. Or there is a 5% chance of me making the wrong conclusion. To make the wrong conclusion. Obviously, the smaller your significance level, the more reliable your data is likely to be, or your conclusions are likely to be, and the better it is. So all the stuff that's going on in the world right now, you'll see them talking about confidence intervals, which is kind of similar, slightly different, but they will have a significance level built in there, probably at 1%, because obviously they have to be really sure of what they're saying. Okay, and then you've got, so P is the proportion, but then you have a P value, and that is the probability of the thing you're measuring. What can I say? Event, so occurrence. I can never remember whether it's got one R or two. I'm going to put probability of the event measured. all of these will become a lot clearer once I start putting them in context. And then, like I say, it's very didactic, prescriptive, if you like, on exactly what it is you need to include. So all of these need to be included. So there's 5 things that you need to include in any answer, as well as a fairly specifically worded conclusion. Right. Oh, the one thing I will say is, so your one-tail test, so you've got a binomial distribution which looks like this. So your significance level would be this bit here. So this here, if your p-value is less than the significance level, I'm going to shorten it to sig, i.e. the probability of it being more than whatever is in that shaded region, then you reject H0, i.e. the change has happened. There is enough evidence. And it doesn't have to be at the top end, it could be at the bottom end as well. For a two-tail, so this is one tail. For a two-tail, still got the same curve, but you're saying it could be in this section or in this section. So this is half of your sig level. And again, if p-value is less than, in this case, half sig level, reject H0. Okay, so you're seeing if the probability of the event happening falls within the regions that are shaded. Right, let's get on to a couple of examples. Right there. So we are starting with boys and girls born during World War II. More boys than girls were born during World War II. A sample of 200 babies were taken, 116 were boys. Does the data support the statement of the 5% significance level? Okay, so the first thing we need to do is write down those 5 things. So we need to write down H0, H1, P, sig level, and I've forgotten the other thing. Oh, p-value. So the p-value we've got to calculate. So H0, no change. Well, it should be 50-50. So the proportion, I shouldn't put an equals there, it should be a colon. The proportion is 50-50. So the probability, if you like, should be 50-50 girls and boys. The alternative, the thing we are trying to test, it says more boys than girls. So we say more than 50% of them were boys. And the thing we were measuring is the proportion of boys in a sample of 200. Obviously, the bigger your sample, the more likely your data is to be accurate. And the significance level is 0. Well, you can either write 5% or 0.05. Okay. Right, so we are using binomial distribution. So we are using binomial distribution with 200 babies, and the probability of boys and girls is half and half. If the probability, let me draw a little diagram, maybe that will help. So we know it should be a 50-50, so the mean is going to be 100. So we need to know if 116 or be there, get my words out. Is that area there more or less than the 5% that we're allowed? So we are finding the probability of greater than or equal to 116. So on a binomial, we can only test less than or equal to, so it's going to be 1 minus the probability of it being less than or equal to 115. So you go to your inbuilt calculator functions, and that will come out as 0.0141. Right, so in other words, there is a 1.4% chance of it being above 116. Okay. So here comes the conclusion bit. We say, since, you can either do this as percent or you can do it as decimal. Most people prefer doing it as decimal. Since 1.4 is less than 5, i.e. the significance level, we reject H0 in favour of H1. And then you say there is, you always have to write this, and it will either say significant evidence, enough evidence, or no evidence. Or not enough evidence, you know, kind of, there is significant evidence to suggest, and you've got to write this every time, and now you put the context in, that more boys, always refer it back to the question, were born during World War II at the, and you have to put the significance level in, 5% significance level. Okay, I'm going to see if I can quickly get through another example. So, Alice is late for school 1 in every 5 days. In the last 30 days she was late 4 times. Has her attendance improved? So H0, no change. So she's late to 20% of the time. H1 has hers improved. So it's got to be attendance to have improved, so the probability of being late has to go down. So we are saying is, whatever that is, 4 times, is this probability less than 0.2? Okay, that's what we're trying to find out. So P is the proportion of lates. I'm going to run out of time. H1, H0, P. Sig level is 10. And we are doing the probability of it being less than or equal to 4, which is, that is 0.255. So we say that since 0.255 is less than 0.1, or 25, greater than, there is not enough evidence, trying to scribble, evidence to suggest her, or that, her attendance has improved at the 10% sig level. There we go. reject, you can put this in any order, reject H1 in favour of H0, or you could say do not reject H0, something like that.